Good morning, Algebra. We're going to talk about scientific notation today. And I don't know if this is honestly a review for you or if this is the first time through this. For many of you, it's probably a review. Scientific notation is just a way to express very, very large or very small, kind of unwieldy numbers in a little more manageable form. You know that if I had a number like 60, that I could rewrite that as 6 times 10, right? If I had a number 600, I could rewrite that as 6 times 100. It's kind of the same method that we use in scientific notation. If I had a very, very large number, 6,080,000, let's say. You know, after a while, that gets to be very much of a pain to write all the time, even if it was larger even than that. But I can break this down by using exponents and by using tens to write it as a little more manageable number. The way that scientific notation is always going to turn out, it's always going to turn out as, where should I write this? I'll write it down here. You'll have a number, decimal, two other numbers, and then we're going to write x. I know that it's kind of the old, what you learned in baby school way to write times, but that's the way they do it. Times 10, and then there'll be another exponent here. So if something is in this form, this is in scientific notation. If we had a big number like this, think about the decimal. The decimal starts here. And for us to get this in this form, we're going to want this number and the decimal right there, and then these two numbers to be in these two spots. So basically, I have to move this decimal over 1, 2, 3, 4, 5, 6 spots to get it in the right spot. Now, when I move it to the left, am I making the number bigger or smaller? Just think about it for a second. Hopefully you can see that we're making it smaller. So I'm going to have a smaller number than my original. So to get back to the original, I'm going to have to multiply it by a bigger number here. So it's going to be 6.08. And again, I'd have to round that if I needed to, but there's a 0 there, so I don't have to. Times 10 to the, and how many times did I move it over? I moved it over 6 spots. So 10 to the 6th is going to be a large number, which is what I want. So I've made my number smaller. When I multiply it by a bigger thing, it gets back to the original number. Okay? Let me erase this just so it looks right. Now, can you see that this number and this number are exactly the same thing? This is expressed in scientific notation and this is not. Let's try another one just for practice, okay? I don't even want to say that number, it's so big, it's horrible. So let's work on getting it down to a smaller chunk. Remember, we're going to move it so that there's a number and then two others as the decimal places, the hundredths place. And we're going to write it times 10 to some power. This is a big number. We're going to be making it smaller, so we're going to be multiplying it by a bigger number to get it back to normal. Think how many times we have to move the decimal place. It starts here. Actually, sorry. Let me just stop, and I'll have you just practice it. Try it on your own. Go. Okay. So the decimal place is here. We have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 times to get it in the right spot. So it's going to be 1.2, and that 7 is not going to stay 7 because the next one over is going to make it round up. 1.28 times 10 to the, and remember we moved it 9 places, 10 to the 9th power. So what you got? All right, I'm proud of you. We also can use scientific notation for small numbers. If I had a number like this, 0.00008654, I'm going to want to put that in scientific notation. In this case, though, I'm starting with a small number. When I put in scientific notation, I'm making it bigger. So then I'm going to have to multiply that bigger number by a smaller number to get back to where I started. So just remember that before we start out. Okay, let's move it so we have the same exact positioning of the decimal place as what we wanted. So move it from here. I'm going to move it so that there's an 8 and then point and then 2 numbers. So 1, 2, 3, 4, 5. So it's going to be 8.65. That 5 is going to stay because that 4 doesn't make it round up. So I have effectively made this number much, much bigger. So I'm going to need to multiply it by something smaller. So in this case, instead of 10 to the, I forgot how many times we moved it, 1, 2, 3, 4, 5. Instead of 10 to the 5th, I don't want to be that because that makes this even bigger. I'm going to want to be 10 to the negative 5th, which makes it much smaller. Okay? So big number times small number gets you back to small number. Some people just memorize, oh, if I move the decimal place to the left, I'm going to multiply by a positive number. If I move it to the right, I'm going to multiply by a negative number. And I think that kind of memorization is counterproductive because you're going to forget that. There's no reasoning behind it. And then you're going to be stuck. It's much better to think conceptually. If I have a small number and I turn it into a bigger number for scientific notation, then I'm going to have to multiply it by a smaller number. And then vice versa. Okay, hope that made sense, and that's lesson number 4.